Hello and welcome to our video on the history of the planet Mars. Mars has fascinated humans for centuries, and its unique characteristics have led to countless missions to explore and study it. In this video, we will take a closer look at the history of Mars, including its formation, geological evolution, and the various missions sent to study the planet. Mars, the fourth planet from the Sun, is a fascinating planet that has been studied extensively by scientists over the years. Understanding how Mars formed is essential to understanding the planet's geological and environmental history. Scientists believe that Mars formed approximately 4.6 billion years ago, around the same time as the rest of the solar system. The formation of Mars is thought to have begun with the collapse of a large cloud of gas and dust in space. This cloud, known as the solar nebula, contained hydrogen, helium, and small particles of dust and ice. Over time, these particles collided and stuck together, forming larger and larger objects called planetesimals. The planetesimals that eventually formed Mars were likely between 100 and 1,000 kilometers in diameter. Volcanic activity has played a significant role in the geological evolution of Mars. The planet is home to some of the largest volcanoes in the solar system, including Olympus Mons, which stands over 21 kilometers tall. These volcanoes formed from the release of magma from the planet's interior and contributed to the formation of the planet's distinctive terrain. Tectonic activity has also shaped the surface of Mars. The planet is home to a massive canyon system, including Valles Marineris, which is the largest canyon in the solar system. These canyons formed from the movement of tectonic plates beneath the planet's surface, and they provide valuable insights into the planet's geological history. Mars, like Earth, is a rocky planet that formed from the dust and gas that surrounded the young sun. When Mars first formed, it was a hot, molten ball of rock that slowly cooled and solidified over time. Volcanic activity on Mars was most intense during the planet's early history, around 3 to 4 billion years ago. At this time, Mars had a much thicker atmosphere than it does today, which helped to trap heat and maintain higher temperatures on the planet's surface. This created conditions that were favorable for volcanic activity, as well as the formation of liquid water on the planet's surface. Impact events have also played a significant role in the evolution of Mars. The planet's surface is covered in impact craters of various sizes, ranging from small craters to large basins. These impact events have contributed to the planet's geological diversity and have played a role in the distribution of water and other resources on the planet. The geological evolution of Mars has provided valuable insights into the planet's history and the conditions that existed on its surface. Understanding how Mars has evolved is essential to understanding the planet's past and present, and the potential for future exploration and discovery. The Mars rover is a robotic vehicle that was designed to explore the surface of Mars. The first Mars rover, named Sojourner, was launched in 1996 as part of NASA's Mars Pathfinder mission. Since then, NASA has launched 4 more rovers to Mars, including the Mars exploration rovers Spirit and Opportunity, which were launched in 2003, and the Mars Science Laboratory Curiosity, which was launched in 2011. The latest rover to arrive on Mars is the Mars 2020 Perseverance rover, which landed on the planet in February 2021. The Mars rover is equipped with a range of scientific instruments that allow it to study the planet's geology, atmosphere, and climate. These instruments include cameras, spectrometers, and various sensors that can detect and analyze the chemical and mineral composition of rocks and soil on the planet's surface. One of the key objectives of the Mars rover missions is to search for evidence of past or present life on the planet. The Mars rover has made many important discoveries over the years, including evidence of ancient water on the planet's surface and the discovery of methane in the planet's atmosphere. These discoveries have helped to deepen our understanding of Mars and its potential for habitability. The Mars rover missions are ongoing, and future missions are planned to continue exploring the planet and searching for signs of life. And there are still signs of water on the planet today, in the form of ice caps and subsurface water. Water is a crucial component for life as we know it, and its presence on Mars increases the possibility that the planet may have once harbored life. Organic molecules are the building blocks of life, and their presence on Mars has been detected by a range of scientific instruments, including those carried by the Mars rover missions. While the detection of organic molecules does not necessarily mean that life exists on Mars, it does suggest that the planet may have the potential for supporting life. In addition to searching for evidence of past or present life on Mars, scientists are also exploring the potential for future human exploration of the planet. This includes studying the planet's geology, atmosphere, and climate to better understand the challenges that would be faced by human explorers. For example, scientists are studying the planet's radiation environment to determine how to protect humans from harmful radiation exposure. The search for life on Mars is ongoing, and future missions to the planet are planned to continue this exploration. These missions will be equipped with advanced scientific instruments that will allow scientists to search for signs of life with greater precision and accuracy. The discovery of life on Mars would be a monumental achievement and would have far-reaching implications for our understanding of the universe and our place in it. Another important objective of future Mars exploration is the study of the planet's geology, climate, and atmosphere. This includes the study of the planet's surface features, such as craters, canyons, and mountains, as well as its weather patterns and atmospheric composition. Understanding these factors is crucial for planning future human missions to Mars and for developing technologies to support human exploration and settlement of the planet. In addition to scientific exploration, there are also several proposed plans for human missions to Mars. These missions would involve sending astronauts to the planet's surface to study the planet in person and to develop the infrastructure needed to support long-term human habitation. These missions would be incredibly challenging and would require the development of new technologies for space travel, life support, and resource utilization. One of the key challenges of future Mars exploration is the need to balance scientific discovery with the protection of the planet's environment. Mars is a fragile ecosystem that is vulnerable to contamination from Earth-based microorganisms, and there is a need to ensure that future missions do not introduce new organisms to the planet that could disrupt any potential indigenous life. Thank you for joining us on this journey through the history of Mars. We hope you've learned something new and fascinating about our neighboring planet. From its formation billions of years ago to the geological and environmental changes that have shaped it, Mars is a complex and endlessly fascinating world. And with ongoing missions like the Mars rover, there is still so much to discover and explore. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to our channel for more exciting content. And as always, thank you for watching.